can either do CrossFit or build a car. Those are your only two choices. Hey y'all. So hey, first we're gonna do is we gotta fill in like a little bit of plate stuff to make all the little holes that are on the inner wheelhouse match up to the frame. But first I've gotta, open up this little area and make something that we can template up to. Pretty simple, but had to pull this out to get started. This episode is all about the finishing details, which I reckon is about 90% of the workload for a project car or truck. Slamming the big parts into place is for sure transformative, but it's the little details that seamlessly connect across the car that really do it for me. This makes me think of the time I told you, oh, I just got one quick thing to do. Ended up beating that whole panel. Try to tell the truth more often. Now I'm really done. I've lost track of how many times I've fit these wheelhouses, but it is in the several dozens. So this is just one more trip around the block. This is a really tight fit. You can't put the inner and outer wheelhouses in together anymore. You got to do the inner and then slot the outer just up in place because the flanging and all that stuff, it just gets to be more than can fit. We'll look at one little detail on how these wheelhouses go together in terms of the seams. Original, this seam right here, both of them go on the inside of the unibody. So like how this is overlapped on the inside. You're tempted in the way that this car goes together really quite poorly to just do stuff to the outer, like or do this on the inside and do that on the outer, but it's not the way it was built originally. And that's at least one part that we're going to stick with. Now you might have seen this tool before, but it's basically a temporary rivet, sort of universally known as a Cleco in the way that nasal tissue is referred to as Kleenex. They came from the aircraft industry way back, and I probably have about 200 of them on the car right now. So, little project to do today. This one's pretty straightforward. We're going to use some pretty advanced cardboard-aided drafting software today. Poster board from one of my niece's little art projects. And we're going to use that to fill in a plate, little gap here between the wheelhouse and the frame. And it's going to be pretty straightforward, but we're going to use this to make a pattern to plate it in, just like I've done over here. All you got to do is you just treat paper like steel. Much less expensive and easier to cut steel, but you just treat it like the steel part. Poster board is nice because it's a good stand-in for like 20 gauge, and you can use cardboard when you're using thicker stuff too. I personally don't like the way cardboard folds, so I use poster board a lot. Or if I really need to get some like curves to it, thick cardstock. In any case, you need to make sure that your area is really ready to be templated. I have got to clearance a little part here. Here's another little piece of history. These are my grandfather's old scissors. Singer was the brand. You don't need a bunch of special tools. You really just need your poster board and a decently sharp pair of scissors, I guess. Pocket knife, maybe. But we're just gonna make a rough template, real rough. And that's about the profile that we've got. Oh, one of the things that does save you time is bring your ruler with you, and then if you can, just do all this stuff right here. You don't have to go back to the table to get grinders and stuff like that. You just get to do it all right here. And in my experience, I usually end up making 2 paper templates before I end up with a final version. So I'm sure I'll end up transferring this to another later. Okay, that's where the bend is going to be. And I know there's a bend because I've already made this one here. And you can see This is where the bend, it's about 3/4 of an inch across. And I'm just going to give that roughly parallel. There you go. Easy peasy, lemon squeezy. Yeah, that's enough to get started. We'll just take this straight to steel and then I'll blend it from there. You can either do CrossFit or build a car. Those are your only two choices. Okay, where's my 18 gauge? All right, so I've already got my SEMA layout fluid on here. So this is leftover from the last one that I made. So we'll just, you know, about like that. That'll work pretty good. These are little magnets. I think I got these from Trick Tools or Eastwood, I don't remember. But they're super handy. All right. Now we just need some straight edges to kind of finish those lines out. You look around, there's always a straight edge. Even the one in your pocket, I learned to draw in school using my student ID as like my go-to straight edge. All right, that's close enough for government work. I have come to prefer carving out the rough shape with the grinder and using the mini table saw for the detail cutting work. There's just a lot of control, and that's useful for intricate shapes like this. Now we got to transfer the bend line. This is a very, very highfalutin, very high-end piece of gear. The sheet metal brake. I don't even think this costs $100. I think this is like a $70 or maybe an $80 piece of gear. What, baby? What? Oh, I see. That's how we're going to be. We'll play ball in a minute, Dumpling. This is one of these things that this is really good for because this is a bend that's maybe like 1.5 inches, 1.25 inches. This is going to bend it no problem. And you're going to make a zillion of these little parts on your car. So this is such a nice, handy tool that you don't have to take up a lot of space with. But I put the scribe line dead in line with the parting line of the brake, and then I scooch this guy up to maybe to the width of the material, which this is 20 gauge, so that's like 0.40, which means I ballpark it. Nobody measures 0.40. You just take a decent guess. And that's pretty good. And because this is so short, you don't need a whole bunch of clamping, but bigger pieces, you know, you can line up the clamps across. And now we're going to give a very exact bend angle. Pretty close. The important thing is you've basically got the bend line on there, and we can do the rest with a hammer on the. Actually, the frame of the car is a great, nice little die. And see, you get pretty close, pretty darn close, but not quite. The angle's not quite right. So there's a little bit to trim here, but we've got the tools to do that. We're gonna hit that with the grinder. There we go. That's about it. Now we just do our little trim, which I think is just that little bit that you want to take off. That is the fit that I was looking for. Sometimes it just pops into place, but it does take a minute. What, baby? What? Hey. Okay. That's gonna pretty much do it. I can feel on the inside here, there's still a little bit of overlap, and I'm gonna just scribe one more line. Now comes the fun part. Get out the welder. One of the things that I use when I'm tacking, I have this variable control button, variable amperage button on here. It's kind of like having a pedal, but you just use the pressure of your finger. And what's nice about that is you can pulse like normal. You can do pulse right there on a seam, but you can do it with your finger. And you know, you eventually figure out how to keep your finger still enough that you're not gonna goober up the puddle. But this has been a super nice add, super duper handy. All right. Once you got one tack, you also can get kind of brutal with this and manipulate it wherever you want. Magnets are awesome until they're extremely frustrating. There we go. That's about right. There's a little bit of a profile that we're going to do here. Show you. So you need to have that a little downward curve to it instead of being, I don't know, janky. That's easy to fix.
Yeah, you can tell your friends I'm gonna walk it down the aisle. You know I can't quit you, baby. Can you hear my heart crying loud?
So there's just a little bit of cleanup to do to make this thing really nice and ready. And some of that means that you're getting the seams right next to each other so that there's only two kinds of welds. This part that's going to have a fillet weld, and then the outer part that will be pretty much an open corner. And I'm just going to use some of my air tool abrasives to make sure that I get those seams all just right. Starting with a fresh abrasive reduces the heat input, which is the whole enemy for keeping thin stuff like this in shape. Yeah, now that's it's all very consistent. It'll weld. I use the same weld technique all the way across. That's really what we're trying to do. But before we do that, I've got to get rid of the layout fluid on the other side. It's going to bother me. It's only obsessive if it doesn't matter. And this actually does have an impact on weld quality, so take the time to clean both sides of the material if you can. This stuff is basically just acetone, so it also cleans the material you're about to weld. You just wait long enough for it to evaporate off, because you don't. It's of course as flammable as acetone, so you don't want to get in trouble there. There's not any heat in that. I mean, it'll be warm to the touch, but I definitely want to make sure there's no acetone on there. Open corner, 040. Let's do 40 amps. No, let's do 50. I'm feeling daring. And let's put in a fresh piece of tungsten, or let's sharpen that tungsten. As happens when you use a piece of tungsten for a while, especially if you've managed to dip it, which, just be honest, that happens from time to time. The amp input to get the profile you want will change. You'll have to use more amps to get the same penetration. So it's always good to start with clean tungsten. That's one of those really high value pieces of gear, that little grinder adapter on the Dremel. I've got it in the store. I really like it. There are some substantially more expensive ones that if you're a pro, you should definitely go and get, but for the rest of us, that thing works pretty doggone good. I'm sucking the tungsten in a little bit more to get better gas coverage. It's not gonna work.
No ground.
No ground. No ground. At least I didn't get to the high frequency bzz, bzz before I realized, oh, what's going on? Dirty tungsten. Oh, baby. Where's the sweet girl? Hey.
Hey.
We'll finish this weld and go throw a ball, sweetie. Probably was doing 30 amps for a lot of that.
The rest, 25, 26.
So it's technically not a weld. I think it's technically brazing. And this just gives a lot of material to go and blend after the fact. So we're not going to settle for that profile. I'll blend it, you know, hereafter. As it stands right now, there's a lot of heat in this, and so we're going to let it relax, let it cool. I mean, there's not a huge wide heat affected zone, sure, but one of the best things you can do for steel is kind of treat it like a piece of steak, right? Let it rest before you start carving into it again. And that's about it. So there's a lot of little details left to do and getting these things blended up, but you guys have kind of seen that before. As we sit here now, it's really just blend, make sure that the profiles all match. Silicon bronze and some steel is going to help me do that. But this is fun. I think it's really neat being able to do just a couple of 2-hour projects here and there. Chris and I did this in like, I don't know, 2 hours, maybe an hour and a half here in the shop. And you can just see, like, right now we do need to stop and kind of go do something else. I can pick this back up and do the rest of these welds tomorrow.
And that's exactly what I did. Over the course of 2 weekday evenings, I burned in and blended these wheelhouse fillers, taking the time to carve the silicon bronze until the radius matched the bead roll bends we did last time. That blending is a slow process. It's a lot of work with round files and the DA and the very edge of a roll lock. Like, it's detailed work, but as y'all know by now, that's kind of my thing. Thank y'all for being here. And until next time, take care.